Good evening, children of class 8th. Today we will be talking about our chemistry video, and this will be the third video of atomic structure, the fourth chapter that we will be doing today. And in this third video, we will be talking further about the electrons and protons. Last time, if you remember, that we studied about atomic number and atomic mass. Let us talk about these further. What are nucleons? Last time I told you that inside the nucleus, we find two kinds of subatomic particles, protons and neutrons. So the nucleus of an atom consists of protons and neutrons, and these are collectively known as nucleons. The nucleons do not take part in a chemical reaction. We see here in this particular atom that in the nucleus there are two subatomic particles, protons and neutrons. Protons, as you remember from the last video, are positively charged particles. Neutrons have no charge, and we see that electrons are negatively charged particles. The electrons are found outside in the shell, and we see that the electrons, they revolved in fixed paths called the shells around the atoms. They move in fixed paths. And these nucleons, protons and neutrons, they remain inside the nucleus, so they do not take part in chemical reactions. If electrons are lost, we see here that there is an electron in the outermost shell, but when this electron is lost, then the positive charge due to protons increases inside the nucleus. So this particular element becomes positively charged. When electrons are lost from the outermost shell, then any element, it becomes an ion, and this is positively charged. The atom here becomes positively charged. For example, let us understand this by taking an element. We see that lithium atom is taken here. The lithium is depicted by the symbol Li. Lithium is depicted by the symbol Li. Lithium has got 3 protons and 3 electrons. We can see here 3 protons and 3 electrons. 1, 2, 3. When lithium loses 1 electron from the outermost shell, we see here that there were 2 shells, and from the outermost shell, 1 of the electrons was lost. Now children, how many electrons are left in the inner shell? 1, 2. Only 2 electrons are left in the inner shell. So when lithium loses 1 electron from the outermost shell, it becomes positively charged, because the positive charge inside due to protons is still 3, while the negative charge is only 2. So there is 1 extra positive charge. So we show the ion, the positively charged ion of lithium, like this. If electrons are gained, then the atom becomes negatively charged. For this, let us take the example of an element called fluorine. Now, this is a fluorine atom which is neutral. Why I say neutral? Because the number of protons that are in the nucleus is 9, and the number of electrons that are in these shells all together are also 9. But when we see in the outermost shell, 1 more electron comes. There were 7 electrons in the outermost shell, 2 in the inside shell, total were 9. But when we see that 1 more electron is added to the 7 in the outermost shell, then how many electrons are there? Total we see that there are 10 electrons altogether. 2 and plus 8 electrons in the outermost shell. So we get the ion, the negatively charged ion of fluorine, which is written as F to the power 1 negative. So why 1 negative? Because 1 electron is extra in the outermost shell and the number of protons remains the same, which is 9. Now let us look at some calculations of how we calculate the number of neutrons in any atom of an element. Based on mass number and atomic number, we can do certain calculations. If you remember from the last video, the letter A represents atomic mass and the letter Z represents atomic number. We can calculate number of electrons, protons and neutrons in the following manner. We learnt last time that number of protons is always equal to number of electrons in a neutral atom. Therefore, the number of electrons are represented by Z, and as they are equal to the number of protons, so number of protons, which is atomic number, is also represented by Z. But the number of neutrons can be calculated as this. A is the mass number. What is the mass number? Mass number is the number of protons plus number of neutrons. So this mass number is A. Out of which we subtract the atomic number Z, which is the number of protons or the number of electrons. When we subtract the atomic number from the mass number, then we will get the number of neutrons. Let us understand this better with the help of an example. Look here, children. You see, lithium atom has got the symbol Li, which we discussed earlier. Now, this symbol of Li has been shown here. This element has atomic number Z equal to 3. The mass number, atomic number is 3 and mass number A is 7. Therefore, the number of electrons is equal to atomic number Z, which is 3, and the number of protons is atomic number 3, which is also shown by Z. Now, how shall we calculate neutrons? A minus Z. What is A, children? Is the mass number, and mass number is made by the number of protons plus the number of neutrons inside the nucleus. So, the number of neutrons is equal to mass number minus atomic number. So, we will calculate 7 minus 3 is equal to 4. So, number of neutrons is 4. Now, let us look at some important things here. An atom is represented by a symbol for the element. For example, lithium element is represented by symbol Li. L is written capital and I, which is the second alphabet, is written with small. Atomic number is written on lower side of the symbol. So we see in lithium the atomic number was 3. It is written on the lower side of this symbol. Lower side. For example, and mass number is written on the upper side. You can see here that mass number 7 has been written on the upper side of the symbol Li, like this, for example. So both mass number, where is the mass number, children? This is the mass number, and the atomic number. It is given here. can be written like this. So let us again write it together. This is the symbol of lithium, Li, of the atom of lithium, and the atomic number, children, is 3 written towards the lower side of the symbol, and 7 is the mass number which is written on the upper side. Let's take another example to make your understanding more clear of sodium. Now sodium is represented by the symbol Na, capital N and small a, because in Latin it's called natrium. So it is written Na. The atomic number 11 is represented by the symbol Z, which is shown here. Z is written on the lower side, and the mass number A, which is 23, is written on the upper side. You can see how we can represent here. Z is 11, so we write the atomic number Z here near the symbol of sodium, and the mass number 23 on the upper side. So this is how, children, you can represent the atomic number and mass number of the atom of an element. Let us define some important terms one by one. We will be looking at terms isotopes, isobars, and isotones. Let us deal with them one by one and understand them. The first one is isotopes. Isotopes are the atoms of same element. We see here chlorine element. So these are the symbols of the same element, chlorine. This is one atom of chlorine written here. So isotopes are the atoms of same element having same atomic number. We see here the atomic number of both these chlorine atoms is the same, but different mass number. You see here that in this chlorine and this chlorine atom, the atomic numbers are the same, but the mass numbers are different. 35 for this chlorine atom and 37 for this chlorine atom. So you can understand and you can memorize this definition of isotopes. Let us look at isobars. Isobars are the atoms of different atomic number. They are the atoms of different elements. What we see? The elements are different here. And they have different atomic number but the same mass number. What are isobars? Isobars are atoms of different elements which are having the different atomic numbers but the same mass number. For example, let us look at two elements, argon and calcium. We see, as we said in the definition, the upper side mass number is 40 in these two elements. Argon, the mass number is 40, calcium also it is 40. But we see the atomic number of argon is 18 and the atomic number of calcium is 20. We see that isobars have different number of electrons, protons, as well as neutrons. Let me repeat this property of isobars once again. Isobars have different number of electrons, protons, as well as neutrons. And the second property of isobars is the isobars have different physical as well as chemical properties. Now, let us come to isotones. What are isotones? Isotones are the atoms of different elements. We see carbon here with the symbol C and nitrogen here with the symbol N. These are different atoms of different elements. Isotones are the atoms of different elements having same number of neutrons, Example, let us see here. We see that number of protons in carbon are 6. You can see here the atomic number or the number of protons is 6. Whereas the number of protons is nitrogen is 7. So the atomic number of nitrogen is 7. Then we see that the number of electrons is in carbon is also 6, and the number of electrons in nitrogen is also 7. So this is in a neutral atom. Carbon neutral atom and nitrogen neutral atom both have atomic number 6 for carbon and 7 for nitrogen. Then we see that the number of neutrons in carbon is equal to 13, which is the mass number, minus 6, which is the atomic number, gives us 7 neutrons. Now likewise, let us calculate for nitrogen. Number of neutrons in nitrogen is 14 is the mass number and 7 is the atomic number. So 14 minus 7 gives us 7 neutrons. So you see here, children, number of neutrons is 7 for carbon and 7 for nitrogen. Therefore, isotones are the atoms of different elements having same number of neutrons. Therefore, when both elements, carbon and nitrogen, have same number of neutrons, these two are called isotones. Carbon, nitrogen are called isotones. So children, wish you all the best. Go through this video many times because these are very important terms and definitions. Please understand them well. Next time we will be looking at the arrangement of electrons in atoms and electronic configuration. We will be looking in the next video. So children, till then, wish you all the best. Have a good day. Thank you.